JEE Advanced 2025, Paper 2, Physics, Question 6. Here is the setup. Two identical concave mirrors, each of focal length f, face each other. Between them, a glass slab of thickness t and refractive index n0 is placed at the center, perpendicular to the principal axis. A point light source S is at the center of the slab, right on the principal axis. The distance between the two mirrors is d. We need to find the values of d for which the image forms on S itself. The question states, two identical concave mirrors, each of focal length f, face each other. A glass slab of thickness t and refractive index n0 is placed equidistant from the mirrors, perpendicular to the principal axis. A point source S is at the center of the slab. For the image to form on S itself, which distances between the two mirrors are correct? This is a multiple correct answer question. Option A, 4f plus the quantity 1 minus 1 over n0 times t. Option B, 2f plus the quantity 1 minus 1 over n0 times t. Option C, 4f plus the quantity n0 minus 1 times t. Option D, 2f plus the quantity n0 minus 1 times t. Let us recall the key concepts. First, the mirror formula, 1 over v plus 1 over u equals 1 over f. Second, when light passes through a glass slab of thickness t and refractive index n0, the apparent shift of the object is t times the quantity 1 minus 1 over n0. The object appears closer to the mirror by this amount. Third, for the image to return to source S, there are two possible cases. Case 1, the apparent object is at the center of curvature, that is 2f, of each mirror. Then the image forms at the same point 2f, and retraces back through the slab to S. Case 2, the apparent object is at the focus f of one mirror. Light becomes a parallel beam, hits the other mirror, and focuses at its focus, which by symmetry is exactly at S. Step 1. The source S is at the center of the slab, so the actual distance from S to each mirror is d over 2. Light from S must pass through half the slab, that is thickness t over 2, before reaching the mirror. The apparent shift due to this half slab is t over 2 times the quantity 1 minus 1 over n0. So the apparent object distance from each mirror is d over 2 minus t over 2 times 1 minus 1 over n0. Case 1. If the apparent object is at 2f from each mirror, that is at the center of curvature, the image forms at the same point 2f. The reflected light retraces through the slab and reaches S, setting the apparent distance equal to 2f, d over 2 minus t over 2 times 1 minus 1 over n0 equals 2f. Solving for d, we get d equals 4f plus t times the quantity 1 minus 1 over n0. This matches option A. Case 2. If the apparent object is at the focus f of one mirror, the reflected light becomes a parallel beam. This parallel beam hits the other mirror and focuses at its focus. By symmetry, this focus point is exactly at S, so the image forms on S, setting the apparent distance equal to f, d over 2 minus t over 2 times 1 minus 1 over n0 equals f. Solving for d, we get d equals 2f plus t times the quantity 1 minus 1 over n0. This matches option B. Now, why are options C and D incorrect? Options C and D use the expression n0 minus 1 times t for the shift. But this is wrong. The apparent shift formula for a glass slab is t times 1 minus 1 over n0, which is not the same as n0 minus 1 times t. The expression n0 minus 1 times t arises in Lensmaker or Prisma deviation formulas, not in apparent depth shift. Therefore, options C and D do not give the correct mirror separation. The correct answers are options A and B. Option A gives d equals 4f plus t times 1 minus 1 over n0, corresponding to the object at the center of curvature of each mirror. Option B gives d equals 2f plus t times 1 minus 1 over n0, corresponding to the object at the focus, where light bounces as a parallel beam between mirrors. Both configurations produce the image back on S. Here are important tips for JEE Advanced optics problems. Tip 1. The apparent shift for a glass slab is t times 1 minus 1 over n0. Do not confuse it with t times n0 minus 1, which appears in lens and prisma formulas. This is a very common trap. Tip 2. In problems with two mirrors facing each other, always consider what happens when the object is at the focus f or at the center of curvature 2f. These are the key special points. Tip 3. At the center of curvature, the image retraces its path. At the focus, light becomes parallel. Both are powerful conditions. Tip 4. Since multiple correct questions carry negative marks for wrong answers, verify each option independently before marking. Tip 5. Always account for the slab shift before applying mirror or lens formulas. If you found this solution helpful, like and subscribe for more JEE Advanced solutions at MAGPIEHUB. See you in the next video.